This class, we will introduce the OSPF virtual link experiment. So first, the introduction. A planning error caused the split of area 0 on an OSPF network of a complaint, resulting in service errors. To address this issue, the network administrator plans to utilize the OSPF virtual link technology. So actually, we create the OSPF process, right? So in common, we suggest we enable the backbone area to be area 0 and the area stand area like the area 1, area 2, and area 3 connect with the area 0 straightly, right? So we don't divide the area 0 to be two parts. And for the stand area, like the area 1 want to communicate with the area 2. So the area 1 will transfer the traffic to the area 0 first, and then the area 0 will transfer the traffic to another stand area, right? So this is a common scenarios. But now, if we use the virtual link, actually this technology to serve the not common scenarios. This is the virtual link function. So here we can see here the two purposes. First is to master the basic principle of OSPF multi-area design. And second is to master how to configure OSPF virtual links and check link status using commands. So here we have to do the basic configuration, do the OSPF configuration, and to design the multi-area, and then we have to solve the problem, and we have to do the virtual link configuration. After this, we can check the link status. Okay, so this is the purpose. And here is the topology. We can see the topology actually, this topology have the area 1 and the area 0, okay? But the area 0 divided into two parts by area 1, right? So it's not the common scenario, okay? And for R1, R2, R3, R4, and we will create the loopback IP address to become the management interface. Of course, we can use this interface to become the loopback interface. And then we will see the requirements for this topology. One is the X and RY interconnection addresses are xy.0.0.x, the net mask 24. So here we can see between the R1 and R2, the IP address is 12.0.0.0. Okay, the net mask is 24. So for R1, the IP address is 12.0.0.1. And for R2 device, the interface is 12.0.0.2. Okay, so this is the example for you to configure the IP address. And another is the IP address between the R2 and R3. We use the 23.0.0.0. Okay, and for the IP address between the R3 and R4, we use the 34.0.0.0. Okay, so it's the same format. We just follow these rules. And then the second requirement is complete the OSPF basic configuration according to the OSPF area plane in the topology. So we will network the gigabit 0 on R1 and the gigabit 0 on R2 interface to area 0. Okay, and for the gigabit 1 and for R2 and R3 device, we will network the interface to area 1. And next, is gigabit 0 on R3 and R4. We will network this interface to area 0. Okay, so this is the network configuration. And then the next requirement is about the issues caused by the split area 0 and address them with OSPF virtual link. So when we configure the OSPF basic configuration, we will do the virtual link configuration. Okay, so this is the requirements for this lab. And next, we will focus on the configuration plane. First is complete the IP address configuration, like the physical IP address and the logical IP address, right? And after this, we will configure the OSPF basic configuration, like the OSPF process, like the OSPF root ID and the network, and so on, right? After this, we will complete the virtual link configurations and make sure the split area 0 logically through the virtual link. Okay, this is the third configuration. So here is the procedure. And for this procedure, first we have to do the IP address configuration. So now we open our environment. And first we have to do the configuration on R1 device. So open the R1 device. And go to the configuration mode. And to modify the host name. Okay. And create the low-back interface. Is the interface turn and set the IP address. Actually, the format is 1.1.1.1 and the net mask is 33. Actually, you can use another way like this. Okay, actually it's the same, right? And after this, we will configure the physic interface. So the physic interface is the IP address 12.0.0.1. The segment is the 24. So after this, we configure the R1 address and use the WR, store the configuration. And next, we go to the R2 device. Okay. And modify the host name is R2. And then create the low-back IP address, and the low-back IP address is 2.2.33, and configure the IP address belongs to the area 1. Okay, so here is the area 1 address is 23 and dot 0.0.2. Okay, and the segment is 24. And after this, we configure the gigabit 0. So for this physic interface, it belongs to the area 0, right? Okay, and the IP address is 12.0.0.2, and net mask is 24. So after this, we will go to the R3 device. Enable configure terminal. Interface low-back 10, and the IP address is 3.3.3, and the net mask is 32. Okay, and then go to the gigabit 1, and the IP address is 23.0.0.3, and the net mask is 24. Okay, after this, we go to the gigabit 0. So for this gigabit 0, it belongs to the area 0. Okay, so the IP address is 34.0.0.3, and net mask is 24. Okay, and modify the host name so that we can recognize this device easily. Host name is R3. Okay, so after this, we will configure the R4. And first, create the loopback 10, and the IP address is 4.4. The mask 32, and the interface gigabit 0. IP address is 34.0.0.4 and 24. Okay, this is the IP address for R4 device. So after this, we can do the ping test between the R1 and R2, R2 and R3, and R3 and R4. Okay, so go to the R2 and ping 12.0.0.1, and the ping test results is successful, right? And then ping R3 is 23.0.0.3. Okay, so it's also successful. And we go to the R4 to test the connection between R3 and the R4. So ping 34.0.0.3. Okay, so it's also successful. So now the director connection is okay. After this, we can do the OSPF configuration. So we suggest you can do the ping test for direct connection after you configure all the IP address. Okay, and then we can modify this IP address host name R4. Okay. So now we have finished the basic configuration for every interface. So now we will configure the OSPF. So first is the router OSPF 1. Okay, and here you can enter the root ID information, and the root ID you can set the loopback 10 interface, right? And now, if you don't want to configure the root ID, it doesn't matter. Okay, so here we can use this command to configure the configuration. Okay, and then network 1.1.1.1 area is 0, right? It's 0, and we can see the R1 is all belongs to the area 0. Okay, so after this, we network the physic interface is 12.0.0.0 and dot 205.15.55. Okay, arrow is a 0. This is the OSPF configuration on R1, and next is the R2. First, to create the OSPF 1 and the network, the 23, this segment to area 1, because we can see for area, actually it's an API device for area 0 and area 1, right? And for the area 0, and we network the 12 segment to this area. And for the 23, this segment, we will network to the area 1, this area. Okay. And network the loopback can be addressed to area 0. And then network another physical IP address to area 0. Okay, when we finish the OSPF configuration, we can start the configuration. Okay, after this, we can go to the S3 device, the same operation on S3. So OSPF 1 and network to the area 1. So for S3 device, actually, we also can see it's the ABR device belongs to the area 1 and the area 0. And for the gigabit 1, it belongs to the area 1. And for the gigabit 0, it belongs to the area 0. Okay. And it's a network 23.0.0.0. The word mask is 0.0.0.255, and the area ID is area 1. Okay. And network 3.3.3 to area 0, and network the 34 to area 0. So this is the S3 device. And next, we go to the R4 device. Of course, root OSPF 1 and then network. And network 34 a area 0. Okay, now we finished all the basic OSPF configuration. So after this, we also can use a command to test the results, like the show IP OSPF neighbor. And here we can see for R4, we have just one neighbor, right? And go to the R3 and show IP OSPF neighbor. And we also can see the 2.2 and 4.4, two neighbors, right? And for R2, show IP OSPF neighbor. Okay, we also can see the 1.1.1 and 3.3.3.3, these two neighbor. And go to the R1, show IP OSPF neighbor. Okay, we can see we have just one neighbor, right? And the state is 4. It means we have finished the OSPF basic configuration successfully, right? Okay. After this, and we have to do the virtual link configuration because the area 0 is divided into two parts. Okay. So here, for the virtual link, R1 cannot see the 4.4.4. So this route advertised to area 0 on R4, and R4 cannot see the 1.1.1 router to area 0 on R1. So here we can use the show IP router OSPF to see the detailed information here. Okay, so we can see we don't see the 4.4.4, and on R4 we also don't see the 1.1.1.1. Okay, so it means we have to configure the virtual link so that we can see the routing entries. Now we go to the R2 device and to do the virtual link. Here we can see actually the area 1, this area departs the area 0 to become the two parts, right? And so we have to configure the virtual link on R2 and R3, these two devices. Okay, so now we use the virtual link command to do the configuration. Area 1, set the area 1 become the virtual link is 3.3.3. Okay, it means the virtual link is between the R2 and R3, right? And use this command. And we go to the R3. And it's the router OSPF 1 and the area 1 virtual link is 2.2. Okay, it means the virtual link's uh, destination for R2 is the 3.3.3.3, and for R3, the virtual link destination is 2.2.2. Okay, so when we have finished this configuration, and the R2 and R3 will become the neighbors. So here we can use the show IP OSPF neighbor to see the neighbor relationship, and we can see a new neighbor relationship between the two devices. Here is the virtual link, right? So this is the virtual link neighbor relationship between R2 and R3. So also we can go to the R2 to see the neighbor relationship, show IP OSPF neighbor. Okay, it also has the virtual link mark here, and the state is the 4. Okay, so after this, R1 and R4 can see the routing entries between each other. So now we check it. Show IP router OSPF. Okay, and here we can see the table has the 4.4.4.4, but before we don't configure the virtual link and we can't see the 4.4.4, right? Okay, and then we go to the R4 and show IP router OSPF. And we also can see the 1.1.1.1, but before we just can see the 3.3.3.3. We can't see the 1.1.1.1, right? So this is the virtual link function. Okay, and for the R1 and R4 can see them each other. So both routes are internal and marked the O router tab. So it's the OSPF routing entries means. After this, we can do the ping test on R1 and R4. So now we do the ping test on our environment. And R4 ping 1.1.1.1 source 4.4.4. So successful. And then we go to the R1 to ping the 4.4.4 source, the 1.1.1.1. And it's also successful. So it means our virtual link configuration is okay. So this is the virtual link lab. And next, we focus on the key points. Okay, key points. So first is apart from the scenario where error 0 is valid, so virtual link technology can be used in scenarios where non-backbone areas are not directly connected to the backbone area. Okay, so for the first scenario, actually is for this topology, and the area 0 is a backbone area, and the area 0 is divided into different parts, right? And another scenario, maybe we will build the area 1 connected with area 2, right? So actually, the area 1 want to communicate with the device belongs to the area 2. We have to transfer the traffic first to area 0, and then the area 0 will transfer to the area 2, right? This is the common way. But now, we see the area 1 connect with area 2 directly. So to solve the communication problem, and we have to configure the virtual link. So in the following figure, the area 2 here is not directly connect with area 0, right? So virtual link technology can be employed to establish the logic connection between area 2 and area 0. So this is another scenario. Okay. So for virtual link technology, we can see the second key point is the area X in the virtual link configuration refers to the area that the virtual link leads to traverser. Okay. So this is the OSPF virtual link lab. That's all for this class. Thank you for watching.